Well, smart problem number 3 for today is about projectile motion. And because this is two-dimensional motion, many students find this topic a little bit difficult to understand. Because a projectile is something that is projected, something like a javelin or a shot put that is thrown up into the air. And so this object is both moving along the x-axis, which is horizontally, and also moving at the same time along the y-axis vertically. That's why it's called two-dimensional motion, because it moves both along the x and the y-axis. Alright, this represents an object that is projected from here at this point by a person. Let's say that the velocity given is at a certain angle of 30 degrees. So this angle is 30 degrees. The angle is taken with the horizontal. And assume that the velocity is 20 meters per second. So when the person throws the object, it is given a velocity of 20 meters per second. So that's the initial velocity. And this velocity can be resolved into two. The horizontal, which is going to be 20 cos 30, which comes out to be 17.32 meter per second, and the vertical, as you can see, is 20 sine 30. So this is what you got to do when you deal with projectiles. The initial velocity, whatever it is, in this case is 20, and the angle could take any value. In this case it's 30, and from the two you got to remember that the horizontal component is 20 cos 30 and the vertical component is 20 sine 30. But what is important here is to understand that the horizontal component never changes. The horizontal component remains constant throughout the motion. So it's going to stay at 17.32 meter per second throughout the motion. But the vertical component is going to be acted upon by the gravitational force, and it's going to change. First, it's going to decrease, as shown in this diagram. As it goes up, it decreases, and at the highest point, the vertical component of the velocity becomes 0. So remember that the vertical component started out at 10 meters per second. It keeps decreasing, and at the highest point it becomes 0. And after that, the vertical component starts increasing, but in the opposite direction, as you can see. So that just before it hits the ground, it goes back to exactly 10 meters per second. Now there are three quantities that you have to find in such problems. The first one would be the total time that the projectile takes to go from A to B, from the starting point to the final point, which we call TAB. And the second quantity is the maximum horizontal distance that it moves, which is XAB. And the third quantity is the maximum vertical distance that it goes. In some athletic events like high jump or pole vault, the athlete tries to have a maximum Y. But in other events like a javelin throw or a hammer throw, the athlete tries to have a maximum X. So these are the three quantities we're going to find. Number one, to find the time it takes, we consider the vertical component only. Now, because these two components are independent of each other, you can just consider one of them. And to calculate the time, we consider the vertical component. And since in the beginning it's going against gravity, the acceleration is negative 9.8 meter per second squared. We're trying to find the time, and we know that the final velocity at the highest point is 0. So in fact, the time that we are going to get in this case is going to be half of the time required. The equation that works is Vf is equal to Vo plus At. Vf is 0 and the initial vertical is 10. So when you substitute those and rearrange, you get the time as 10 by 9.8, which is 1 second. And therefore the total time that it takes would be double that. That would be 2 seconds. This is how you find the time of flight. The second quantity that is to be found is the vertical displacement, and because it's a vertical quantity, again we only consider the initial vertical component, which you remember is 10 meter per second, and Vf is again 0. Acceleration is negative 9.8 because in the beginning it's going against gravity, and only what happens in the beginning is important. And we're trying to find delta y. The equation is Vf squared is equal to V naught squared plus 2a delta y. 10 squared is 100, and the negative is because a is minus 9.8. 2 times 9.8 gives 19.6. Switch sides and make delta y the subject. Get 100 divided by 19.6, which is 5.10 meter. And so this is how you calculate the maximum height. And the last quantity to be calculated is a horizontal quantity. It's the horizontal range, and because it's a horizontal quantity, we are only going to take the initial horizontal velocity, and remember that was 17.32 meter per second. And also remember that that never changes because the gravitational force does not act on the horizontal quantity. And now since it's a constant, and we already know the time that it takes to go from A to B, to find delta x, all we got to do is multiply 17.32 with TAB, which in our case was 2 seconds. Therefore, the horizontal range is 17.32 multiplied by 2, which comes out to be 34.6 meter. And this is how you calculate the horizontal range.